In the 17th century, there were two major chemical technologies advanced by saltpeter or potassium nitrate, gunpowder a tool for killing and fertilizers a tool for giving life. But I want to talk about saltpeter and fertilizers. During this time in England, saltpeter fertilizers were studied under the spiritual and philosophical framework of alchemists. They believed that saltpeter, able to seemingly facilitate life as a fertilizer, holds a key ingredient to understand the life forces at work in the universe. Their theories would lead to systematic experimentation and is one step in the history of modern chemistry. I want to talk a little bit about this. I think this is a fascinating topic, and I hope you do too. First, what exactly is saltpeter? Saltpeter came from microorganisms oxidizing nitrogen in organic matter, such as dung, carrion, and plants. In the 17th century, it was a key commodity as a material to create gunpowder. The security of saltpeter production was a national priority for European countries. So, how to produce it reliably? In this time, there is the profession of saltpetermen. They were given royal permission to dig and scoop up saltpeter from soil as they'd like, to the grievances of landowners. They were also stigmatized. After all, most of what they dig up is poo. Diggers can theoretically mine natural saltpeter deposits. However, massive amounts of saltpeter needs a suitable climate to develop. This means an optimal combination of wet and dry seasons that only appear in certain places on Earth. By the 17th century, England, through the EIC, had established a colony on India. Indian climate allows the production of saltpeter in large amounts. Eventually, India enables a consistent flow of saltpeter to England, which allows entrepreneurs and alchemists to experiment with it. This is not possible to most European states. Instead, saltpeter production takes place in a refinery. Here, soil is seeded with defecation and tended to for months before saltpeter could be harvested, much like farming or gardening. Animal dung and urine is piled with dirt, which needs to be kept away from rain and burned often. This part of the process can take months or years until what crystals are visible on the pile. I should say that this method is very hard, which I will discuss later. These methods are believed to originate from China, which traveled through India to the Ottomans and then to Europe through Phoenician merchants, though some historians disagree. The method was then set to tax by alchemists and producers in Europe. But let's take a time to discuss about alchemy. Alchemists believed in vitalism. They believed that all life contained an animating element that distinguishes it from non-life. Alchemists sought to manipulate or isolate this universal life force so they can create works like the Philosopher's Stone or the Elixir of Life. Within this context, alchemists of the time have special interest in saltpeter. Saltpeter has diverse uses. It's used to make gunpowder, but also fertilizers, meat preserves, medicine, dyes, and glass. Alchemists thus view saltpeter as containing a universal spirit, which according to their vitalist theories is a critical component in the animation of organisms and minerals. Understanding saltpeter means understanding this elusive component. The ideas of the alchemist Paracelsus were influential at the time. He proposed the tria prima of salt, mercury, and sulfur, as comprising the fundamental properties and behaviors of all matter. Salt represents solidity, mercury with fluidity, while sulfur combustibility. Prior to the time, it was believed that mercury is the most important basic alchemical ingredient, but this period sees the rise of the sal nitrum school, which sees salt as more important. Large-scale study of saltpeter was only possible in 17th century England, as an abundance of saltpeter from imports allowed the alchemists of England to make systematic efforts in studying it. Following this, alchemists began deeper investigations on saltpeter. They experimented on its properties and effects. Many advocated it as medicine, and they speculated on its production and transmutation possibilities. During this time, Samuel Hartlib was an intellectual figure who connected alchemists, philosophers, and experts in different sciences through his network of letters. Those connected in his network were later called the Hartlib Circle by future historians. Hartlib was a utopian thinker. He envisioned a prosperous society free from hunger and disease. He believed that alchemical techniques can help in this. Influenced by vitalism, Sam Harlip sought to harness the universal spirit of life to achieve this goal. He wrote about saltpeter and of the lack of knowledge about it. He wrote that a natural body of too noble a nature and the universal use for it to be so much neglected and unknown as hitherto it had been. He frequently communicated his ideas to the massive interdisciplinary network of intellectuals. Many in the circle also grew attached on this vision of a society prospered by alchemical means, and many experimented on fertilization and saltpeter production. It was through the Harlip circle that the eminent members of the English intelligentsia were able to gather and coordinate their work together. Alchemical inquiries then became collegiate and not individual, and to some extent collaborative. They proposed that performing alchemical operations on plants, such as crafting or hybridizing, or applying enriching elixirs or powders to the soil or seeds, can lead to large-scale agricultural reform which would benefit society at large. Benjamin Worsley, as one historian put it, was the resident saltpeter expert of the Harlem Circle. He was originally a surgeon who, after a bump in his career, tried to make a name for himself with dabbling in alchemy. After studying alchemy in Amsterdam, he concluded that all plants contain in them salts. Nature's intent in the breeding of saltpeter in the upper surface of the earth is for the generation of plants and by them for the preservation of animals. Indeed, Worsley too was much influenced by vitalism and Paracelsus. He believed that successful experiments would allow him to harness the nitrous universal spirit of saltpeter and through it improve agricultural yields. Worsley proposed a method where nitrous earth is covered with lime, vegetables, and dung as a sustainable saltpeter farm. Robert Boyle, who later became the father of modern chemistry, corresponded with Worsley and modeled his saltpeter production after his. Worsley's idea was to provide employment to the poor working in saltpeter production. They will be situated in workhouses, complete with lodgings, where workers will produce saltpeter by combining their own defecation and other organic materials. The workhouse comes with refinery equipment also, like furnaces and boilers, to refine saltpeter. He claimed that he can produce saltpeter faster and save the state 20% of their saltpeter expenditures. He proposed that this scheme will not only provide employment to the poor, but also serve state interests by providing a steady supply of saltpeter, themselves quite important as gunpowder material. The flow of consistent saltpeter from India led many in England to experiment with saltpeter as fertilizers. Strangely, saltpeter itself is made using materials which can be made as fertilizers in the first place, like manure and nitrous soil. Alchemists, however, believed in the concept of multiplication, and that natural resource is limitless. Alchemists like Worsley and Boyle believed in a possible perpetual mine of saltpeter, which can be developed through experimental methods. Another illustration is the alchemist and farmer Peter Smith, who proposed that land is first fertilized with manure to grow plants. After the plants are harvested, leftovers of the manure would take the form of saltpeter, which can be harvested for reuse. Despite the enthusiasm for saltpeter experimentations, the scientific community continued to experience difficulties. To begin, massive, large-scale production of saltpeter, enough for agricultural reform, was never successfully put off. Indeed, Sam Harlip received many letters proposing innovative means to produce saltpeter, but these tend to be dubious. For example, one wrote of a secret method using lime and chalk. Another exaggerated a method which would make an everlasting mine. Even Worsley, after his time in Amsterdam, claimed to know of a secret ferment critical to making saltpeter. What it was specifically was never uncovered. Indeed, there is a lot of speculation and uncertainty on their methods. The fad with saltpeter eventually comes to an end. Worsley himself, despite being known for his innovations, never really did scaling his projects into large-scale industries. He would later go on to pursue other political and intellectual projects. Robert Boyle moved on to other projects too with an American alchemist. Meanwhile, Sam Harlip tried seawater desalination. Despite his excitement, nothing big came out of it. When experiments were successful, they were no more than impractical prototypes. Thus, there was no big development of saltworks that the collective endeavors set out to achieve. The agricultural reforms some of the alchemists dreamed of were not manifested. This failure is largely because the fact that saltpeter production in the 17th century style is extremely hard. alchemists would argue with one another, calling the other's method to be fake, inauthentic, and unlike anything an actual craftsman would do. This difficulty was directly examined by historians trying to replicate the 17th century method. Several such attempts failed, producing no saltpeter at all. Later experiments would succeed, but this was not without tremendous difficulty and confusion on the scientific explanation of how the method worked. For example, while they managed to produce saltpeter crystals, they did not see white crystals scattered in the dirt pile, contrary to the instructions from the historical documents. Saltpeter production is exceedingly difficult. The legacy of alchemists' work on saltpeter, despite the limitations, were influential years after. Farming manuals up to the later centuries instructed readers on the importance of saltpeter as fertilizers, although there is weak evidence that common farmers regularly consult on these manuals. In the 18th and 19th century, views on saltpeter were shifted, seeing it more as a powerful pesticide and less a fertilizer. Even today, potassium nitrate is not a major component of most fertilizers. The alchemists of the time, unsuccessful as they were in growing saltpeter, were successful in growing a massive research culture. Indeed, while alchemists hold primitive physical theories compared to present-day science, they were keen to conduct systematic empirical experiments to innovate and corroborate their theories. It was only in the early 20th century, through the Haber-Bosch process, agricultural revolution was indeed possible, but this dream was envisioned centuries prior by the alchemists. Though unsuccessful, they deserve credit for their incredible vision, limited as they were by their primitive chemical understanding.